Thank you, Julie. Good afternoon, everybody. So today I've managed to convince Graham Ackroyd from Select Access to come along to do a talk for us, guys. Graham and Select Access are experts in height safety systems to do everything from designing systems through to supplying and installing systems, generally for working at height and particularly working on facades and roofs of buildings. They're a good group of lads. They're always solutions based to come up with some really good solutions. Hence me asking Graham along today to have a chat. So without further ado, Graham, I'll let you do your thing.
Thanks, Ben, and thanks, folks, for the invitation. As Ben said, I work for a company called Select Access Safety Systems, and this presentation is going to focus on height safety systems, their application, roles and responsibilities. So just briefly, my name is Graham Ackroyd. I've been working with Select Access for nearly 5 years now. And I've been working in the work at height industry for over 20 years, and I've been an industrial rope access level 3 for over 19 years. I've been involved in designing of safe access systems and successfully finding safe access solutions over a wide range of industries, working with our construction and design partners. Just a quick overview of the Select Group. Was started as Select Roofing in 2001, operating throughout the Republic of Ireland. It's made up of 3 key elements from the roofing and height solutions, including Select Roofing, Select Access, and LPI, or Lightning Protection Ireland. We have design teams, including chartered engineers, specialising in each core area. The Select Group provide a unique service for our clients. Our SMEs employed in each core unit ensure that all items are fit for purpose for the end user and client. This is part of the operation is the key offering from the group, ensuring that full conformity and longevity of the systems. Highly trained installation and inspection teams with years of industry experience are employed by the Select groups, with teams being widely considered the market leaders in all their disciplines. Each facet is managed by industry leaders with focus on client-driven solutions, with lean principles applied and environmental considerations at the heart of what we do. The Select Group is an ISO 9001 accredited, 2015 accredited, and the Select Access CPD provision that we supply to all inquiries are both recommended by Engineers Ireland and RIAI, or the Royal Institute of Architects of Ireland.
Graham, your presentation isn't moving on.
Oh, my apologies.
I'm not sure what's happened here, but I can just see the first slide.
Move the window away from the shared application. It's pausing the shared screen.
Can you, maybe you could stop sharing and reshare again?
Yeah, just sorry. Apologies, folks.
That's okay. We can cut this bit out. When you share your screen, if you can share your PowerPoint presentation, if you click on the down arrow under the share your screen,
yeah,
you should be able to pick the actual PowerPoint presentation.
Okay.
So you should be able to pick the, it should say PDF PowerPoint presentation.
Okay, is that sharing there now?
Yes, if you just click it into, I'm having a couple of comments coming through saying the sound is pretty bad as well.
My apologies. I'm afraid this is one of those that I can't do much about. Are you seeing that now, Highlander? It should be coming up the Select Group.
Yes, it's moving now. I can.
Oh,
yeah, it's moving now. Okay.
So okay. So just briefly, we're a relatively large company and we're growing. With a staff of over 95 employees. We're customer driven, customer focused. With our in-house design teams, innovation and ingenuity is where we believe that we are the market leaders. But we will also look at the value engineering our systems to provide the best solutions. All of our designs and installations are insurance backed, and our interaction with the client begins at design stage. The Select Access portion of the Select Group are specialists in providing working at height safety systems and access systems. Select Access are Ireland's leading work at height consultants and we operate throughout Ireland and the UK. We provide safety system solutions to many different industries, including construction, facilities management, and oil and gas specializations. This presentation is designed to provide detailed legislation, product and installation information to allow the attendees to specify and integrate work at height systems into their projects. We will cover the key items of the design and installation, maintenance and inspection to all relevant items. I will note at this stage, folks, that this particular presentation was designed for the UK market, so the references in here will be of the BS standards. We're fully capable and to work to any applicable standards throughout the EU. So a brief introduction to working at height. Sorry, Linda, has that moved on? There we go. My apologies. I'm in the right place now. Where am I? Yes. Sorry about this, folks. I'm getting there. To allow focus on the required elements of this work at height CPD, the following aims will be allow the relevant topics to be captured. What is work at height? An introduction. Review specific applicable legislation. Highlight the duties when designing and specifying work at height safety systems. Explore the hierarchy of risk. Discuss the design requirements and access strategies. An overview of the solutions, the benefits of each access solution, and detail the testing and maintenance requirements. As with all parts of the construction of project, the early engagement of access specialists allows the design team to ensure the requirements for the recommended systems can be met by the structure. With the hazards identified during the completion of an access risk assessment, a detailed access strategy can be, where practical, designed out using collective protection. Where this is not possible, the consultant and the design team will apply the hierarchy of risk, which we will discuss further in the next section of the CPD, to provide both the safest and most practical solutions. As this work is completed at design stage, the designer can include the structural requirements for the systems into their design. During this process, gating issues can be identified, such as the limited access space where the reconfiguration of materials may be required. The designer and consultant can now specify the materials and produce the tender. Once construction is underway, the designer and the consultant must ensure that the installation company is competent and that their products meet the required standards. The installation process must be monitored to ensure the compliance with the manufacturer's installation instructions. The installation process must be documented and photographic records are highly recommended. The designer must ensure that the installation teams provides evidence of any and all testing completed, with system completion certificates supplied. The designer and the consultant must ensure full access is viable as per design upon completion of the installation. As part of the handover package, the access system certification will be provided along with an operation and maintenance manual, or O&M manual. The statutory requirements for inspection, including the timelines and the type of testing, must be provided to the client to allow them to add this to their asset register. The assumption that the installation company will return to carry out the inspection cannot be made, and as such, all information must be supplied so that the third party can complete their asset register and their timelines for testing. Any work at height or operation carried out where there is an exposure to height provides risk to the operative. The design team are responsible for the provision of correct systems which are both conform to the required legislation and provide access required by the end user. The design team should engage a specialist company to provide an access strategy consisting, but not limited to, an access risk assessment taking into consideration design, installation, and end user risks and impact to third parties and the facility. System requirement, including detail on the relevant standards. Full layout drawings, including plans and section detail. A formulated access strategy document is the preferred method to provide the information for the tender process. Manufacturers must demonstrate the system testing certificate and, where applicable, material product certificates. Installed by certified competent people, training will be carried out by qualified instructors knowledgeable in the systems involved for the end user. This training should be site-specific to ensure the end user is conversant with the specific systems. Testing is a legal requirement and must be maintained in line with the statutory requirements to maintain the safety of the end user and full insurance cover. As I say, folks, this covers the BS standards, but where we look at this, we have also the EN standards when we're looking at our personal fall protection equipment, including anchor devices, and also when we're looking at personal fall protection equipment, anchor devices, and this is particular when we're looking at cable systems, which we'll come to later under CENTS 16415, 2016, my apologies. As we move through, you'll see the different standards is applied to each of the different systems we're discussing. When considering the best access solution, and the needs of the final facility owner must be considered. To ascertain this, the design team must firstly consider the reasons for access. For example, if the access is purely for cleaning, then simple rope access solutions are hard standing and access available for mobile elevated work platforms, or MEWPs, or lorry mounted hoist can be considered. Progressing this example, we need to consider a number of the following items. The hierarchy of risk to ensure that each solution is considered. Consider the surrounding environment and third parties who may be impacted. If the MEWP and lorry mounted hoist option is progressed, the following needs to be considered. Access both the physical environment and the load bearing of the ground area. For example, is there an underground car park? What height is it needing to reach? This determines the weight of the machines required. Due to the fact that these items are mechanical, they generate noise which can impact both the facility's tenants and those in the surrounding facilities. As other buildings could be residential, there will also be likely be time limits for these operations. As these units are generally diesel and therefore have an environmental impact as they are maintained running during the process, the hire of these items and the potential requirement for street closure permits can have a financial impact to the end client. Using industrial rope access methods, the following needs to be considered. Access to and from the building has very limited impact. However, clear access to the route separate to the facility's main operating areas is desirable. Anchor systems need to be installed at roof level or at different levels depending on the requirement, at a frequency of 2 meters per anchor and set back 2 meters where reasonably practicable. This requires the design team to provide suitable substrate to take the loadings required. Ideally, rope access going over the parapets directly should be avoided unless reinforcing to take place a potential point load of between 4.3 and 6 kilonewtons is built in. The area to which the operatives will descend needs to be clear of obstructions and fully accessible. As you can see, even reviewing the difference between two simple solutions raises questions. This is without adding the potential requirement for glazing and facade changeout, electrical maintenance and mechanical maintenance. Another exercise which should be undertaken to demonstrate the best potential option is a review of the return on investment for the end client. By firstly considering work at height options, in the design, the hierarchy of risk must be applied. Although avoiding working at height is the preferred option, this is not always an option. The designer must, where reasonably practical, allow for the use of collective protection, whether by design of the structure or by adding collective protection measures to provide position of safety for the end user. Where collective measures are not possible, the elimination of the possibility of a fall must be made the priority using guardrail or work work restraint. Please note that work restraint systems must still conform to EN 795 CEN TS 16415 because this system may be misused by a third party and they may use it as a fall arrest system. There is no difference between restraint and fall arrest when it comes to certification. When all other options have been exhausted, fall arrest can be considered. A detailed rescue plan is required to ensure the operative can be recovered from the suspended position rapidly. Suspended access systems, cradles or BMUs. A full design detail for a BMU or a cradle system, including loading and force impact calculations, must be presented for review by the project structural engineer. Equipment must be produced in accordance with the required production directives to ensure conformance. Full inspection completed with the testing in accordance with EN 1808-2015 witnessed at the manufacturer's facility, a full inspection of all components on arrival to site, and a full commissioning testing completed and documented. The design team have a responsibility to ensure that the competent company is engaged and that the required insurance is in place. Ensuring that the product and installation design meeting is meeting the required standards, the design team's responsibility. The use of an access consultant can assist greatly during both the design and installation phase to ensure the correct installation company follows the process correctly and required testing is completed. A review of the difference between permanent systems against temporary used in construction or for one-off access for planned preventative maintenance is ordinarily the main reason for the installation of a cradle systems. By accessing all areas, maintenance and facility lifespan can be managed. Ease of access after training for qualified contractors to perform both PPMs and reactive maintenance. Consideration for material hoist must also be made when we're considering reactive maintenance, glazing replacement, and facade replacement. The designer and consultant need to determine whether the use of a permanent system or a temporary system is best suited. Ordinarily, the permanent system is preferable, with the temporary system being used only during the construction stage. The permanent unit can also be used during construction if fitted with a material hoist. The unit can be installed once on the roof is in place, thus allowing it to be used for the facade and glazing installation. This is not an option which is normally considered, but in tight areas may be the best solution for the construction teams. When designing the SEA, the designer must ensure that EN 1808-2015 is followed and demonstrate this through design drawings and detailed product data sheets. Full details on the loading of the unit in all configurations. The designer must ensure that the unit's interface with the facility is both practical and possible. The full motion of the unit must be demonstrated. Clear detail on the proximity to the facade for the end user, ensuring all possible operations are considered. The layouts of the track were required to ensure clear integration with the site M&E layouts and any other roof located systems, for example, AHUs and chiller units. The access provided for the end user must be clearly detailed. As with all designs, the supplier must provide a full suite of drawings detailing the interface, dimensions, and loading weights. The design of the system must be clearly show the space required for the full operation. Detailed design of the attachment systems to the building where applicable. This must detail locations in accordance with the design grid lines, the embedment depth of the fittings required, the loadings including the moment, clear dimensions to be detailed in the rail systems, including the section drawings. Also to be considered at this stage, the height of the building and the drop of which the unit may be required to go down, and whether restraint fixing at anything up to 40-meter distance need to be installed on long drops of buildings in excess of 40 metres in height. When we're looking at the BMU units, we're looking at different loadings. So for example, we have a total suspended load, which is the unit which also incorporates the operatives with the tools they're going to use. The rated load is the load designated by the manufacturer, and also we have the working load limits of both the hoist and the cradle system. Static test of all of these is carried out when the unit is not in motion, and the dynamic test is also completed during motion. These are carried out both during the manufacture of the system and on the testing and commissioning of the unit, and on an annual basis carried out by specialist contractors. Safety is key when working at height, and this is fully considered during the design of units. As with all working at height, the PFP, the principle of the system backed up, applies to the BMU. The units must have a working system and a backup system. Ordinarily, the BMUs have two main winches with backup units. Supporting the service brakes must also be a manual emergency lowering facility in case of power loss during operation. The BMU must have a manual lowering and raising facility to comply with EN 1808-2015. This must be simple by design and easy to operate by the end user. The use of manual raising and lowering system must form a key part of any training package. By incorporating a material hoist onto the BMU or cradle system design, this allows the architect to facilitate the future change-out of glazing or facade systems. The decision in relation to this can be made during the design base and the risk assessment. Considerations such as the potential requirement for glazing and facade change-out, and no access for conventional systems such as cranes or MEWPs. This removes the requirement for craneage and potentially costly access issues for road closures. Even with the use of the craneage, the change-outs will require support of engineers either in a BMU or using industrial rope access. The material hoist must be fully integrated with the BMU unit and give the end user full control and a preset load limit sensors. Simplicity is the key to ensure the ease of operation for the end user. Easily identifiable control panels with large control switches including only the key requirement functions. The control panel must be easily accessible whilst being positioned so accidental activation can be avoided. Controls must allow the end user to fully access all areas in accordance with the scope document prepared by the designer and the independent specialist who produced the access strategy. In accordance with the EN 1808-2015, the control buttons must be of a medium diameter of no less than 10 mil. Clear visual diagrams must be present to demonstrate the function of each button. Emergency stop buttons must meet the required standard and be clearly visible and directly accessible. Training for the end users is critical for these units. Clear theoretical classroom-based presentation followed by physical demonstration and the attendee actively demonstrating an understanding of all required functions. This must be provided by a system specialist with an instructional qualification. The attendee must demonstrate the key functions to the satisfaction of the instructor and the results documented. An attendee question paper should also be completed to confirm the understanding of the unit. This training should be by BMU specific, and no two units or the environment in which they work are the same. The unit should be fully tested by the manufacturer prior to shipping, as we discussed earlier. The manufacturer should invite the installer and the client to witness the testing. In addition, the installation team should attend the manufacturer's base to run through the installation program and the functionality of the unit. This testing must be carried out again to EN 1808-2015 and be fully documented with details sent to the installation company for the final handover file. On completion of the install, the installation company's competent persons will complete on-site commissioning by fully running through the test requirements in accordance with the N1808/2015. All certificates and manufacturers' unit documents must be shared as part of the unit handover, and this will also include any electrical schematics. Prior to award of the contract, the designs provided must be checked to ensure compliance with EN 1808, and the design team must ensure compliance and engaging specialist company and qualified engineers to review and consider best practice. All drawings must demonstrate the required information in accordance with EN 1808, and this must include the weight loadings of the machine and the loads which will be applied to the structure. The O&M manual must contain both operation instructions and maintenance instructions, which can be used by third parties and not just the installation team, and the maintenance contract may not sit with the installation company. Verification of the BMU system should be carried out on-site by the manufacturer or authorized representatives on the completed installation in its working configuration. Where safety of the system is reliant on correct installation, a thorough examination report confirming that the complete SEA system has been correctly installed and is safe for service should be available prior to the verification of the BMU system. The BMU system, therefore, includes components not covered by the type test within the standards, such as cast-in, welded, or other not readily accessible tracked fixings and joint rail systems. The competent person responsible for the verification should have personally carried out the examinations of any fixing details that have become partially or fully inaccessible during the installation, or be able to refer to suitable, reliable documentation confirming correct installation. Moving on, folks, we'll now cover the use of industrial rope access. Industrial rope access gives the perception of a high-risk activity. However, this is far from the case. Due to the nature of the work and the training, assessment, and management of rope access teams, this ensures that statistically it is the safest means of access in the work at height industry. The use of highly qualified operatives using rope access as a means of access allows quick deployment with limited, if any, impact to the facility or the occupants. Low impact solution for design, installation, and a very low environmental impact for any facility. Industrial rope access is a means of access only. Many trades can be completed by qualified operatives, including electrical, mechanical maintenance, glazing and facade changeout, plating and blasting, and inspection, to name a few. This makes it a realistic option for building designers. The Industrial Rope Access Trade Association, or IRATA, provides guidance and leadership to maintain a high level of safety and access solutions. Industrial rope access was developed in the mid-80s by like-minded climbers and cavers. The forerunners identified a market in the oil and gas industry where rope access could be used to access spaces more rapidly than scaffolding and at a far reduced cost. The industry has mushroomed from there, with specialist company operating in the UK and worldwide. Although membership in the industry is not a requirement, it does speak to the service provider's approach to the operational standards and safety. The International Code of Practice, or the ICOP, is recognised as the core document for the use and management of industrial rope access techniques. This document advises on the training of the operatives, the equipment and the required standards, equipment application, and health and safety procedures for qualified operatives and for those managing the work. Highly managed operations allow the task to be carried out at low risk to the operatives. The management and the methodology and the maintenance of the equipment, coupled with continuous training, ensure that the safety standards are maintained to a high level. As I noted before, rope access is, however, only a means of getting to the workplace. Operatives have a variety of skills and qualifications which allow them to achieve outcomes which previously required the use of scaffold at a great cost and can be time heavy. Skill sets, including cleaning and electrical, as noted before, allow their rope access to provide quick and efficient access solution which has limited impact to the facilities or the occupants and even the local environment. Return on investment models, or ROIs, can easily be used to demonstrate the cost effectiveness of removing the requirements for access permits, high cost maintenance, for example for BMU and cradle units, and the cost of lorry or MEWP units. In addition, the use of rope access teams creates minimal disruption to the facility and occupants. Access to the roof space or location of the certified anchor or davit system are generally through common areas, and the rope access team are silent running with only the potential for minor visual impact when descending past windows. In some instances, the buildings in excess of 100 meters high with a re-belay is required to allow a full coverage of the building. The designer must, however, ensure that intermediate anchors fully comply with the same loading requirements as those of the roof. Scaffolding, for example, is a cost-heavy solution with a physical visual impact for the facilities users. Scaffolding costs both in the erection and removal or striking of the system, as well as a higher cost for the duration of its being in place. As with all access solutions, the design team have the responsibility to ensure that the systems are fully checked, including the equipment has the relevant test certificates in place. The testing certificate must be from an independent test center, which is authorized to carry out the required standards. Certification must form part of the installation contractor submission to allow the designer to ensure that the specifications are met fully. The required loadings can be borne by the facility structure. With all calculations fully checked, the installation contractor must include detail of the anchor system, the calculations relating to this, and the embedment depth and loading to demonstrate conformity with the manufacturer's requirements. The appointment of a competent design installation contractor with the required knowledge, experience, and demonstrated track record is a key milestone for any project. The contractor should be able to demonstrate similar works completed with contact details for the clients involved. The designer consultant should monitor the installation progression from first in kind and sample test through spot checks and on completion. Full testing must be testing documentation with pictorial reference must be provided. The handover package to the facility owner must contain all relevant certification and the O&M manual. A davit arm system provides a solution which removes the impact to the parapet. This system eliminates the requirement to reinforce to take a load in excess of 4 kN of an unfactored load. To provide a parapet to withstand the required forces can add a far greater additional cost to the project than using a davit arm system and remove the pressure from the parapet. This also allows access over balustrade units, maintaining the rope system clear of them. If considered at design stage, the base units can be incorporated into landscape design in a public access areas, as detailed in the picture to the left. The davit arm units are fully removable, which allows the designer to create an access without compromising public space and the visual design. We note here, we can see in the first picture, a fully designed installed davit base with a thermal brake in place. The thermal brake can be incorporated both to chemically fixed units and for casting units. In this instance, this system is also supported by a fall arrest rail back from the scaffold edge that we can see there to allow safe, full access for the end user when working in this location. Another alternative is what we call a dual post or a mushroom post system. This system is installed in the normal way and allows the rope systems to actually go over the parapet with a loaded parapet. You can see there with a concrete upstand, allowing to take the loadings that may be generated. Another option for rope access is what we call monorail systems. A number of manufacturers provide these, but the principle is the same. They're fixed into the main structure with the required loads provided at design stage so that the structure, it can be confirmed that the structure will take the required loadings. The rail systems, for the most part, utilize shuttle units which move freely on the rail, but can, where required, be locked into place so the end user can maintain a fixed position. The design should give clear detail of the interface with the structure and be incorporated into the existing designs and sections. The fixing type, the embedment depth should be detailed. The minimum distance from the leading edge must be detailed, and calculations providing the required tolerances are met for the location are supplied. The specialist designer must also provide detailed drawings to demonstrate that the solution provides access to all areas detailed within the scope document. This is the fundamental requirement of all access systems, and the designer should demonstrate this both on the plan drawings and on provided elevations. And now we'll move on to something which is probably more commonly known as a work fall arrest or work restraint system. The most common access solution is the cable-based system. It has been the go-to option for designers for many years. As things change, the application, the hierarchy of risk is applied. Collective protection must be considered in the first instance. However, when not deemed practicable or suitable due to the design and planning restrictions, the cable-based system offers a reasonable alternative. At this point, the designer must consider the additional training for the end user and the additional equipment required. The terms work restraint and fall arrest, as I noted earlier in this presentation, are used when discussing these systems. To be clear, these refer to how the system is employed by the end user, as there is no difference to the installation and certification requirements under EN 795 2012 or CEN TS 16415 2013. The system must conform to this in the potential for any end user. It is the standard that has to be maintained in case of misuse. These systems are low maintenance with annual inspections required. This, however, may be more frequent depending on the environment and under the direction of a competent inspector. These systems are low impact both physically and visually. The designer and the building management team must, where reasonably practical, ensure that the end user must not be exposed to a fall. As such, the systems are designed to maintain the end user in a position of safety by providing the appropriate equipment to allow access to the leading edge, but preventing movement over the edge. A continuous cable system allows full access with minimal changes, reducing the risk of incorrect application. The system, where possible, must start at the point of entry to the space and terminate at the same point, removing the requirement for the end user to carry out a changeover and removing this potential hazard. These systems can be applied to a number of applications, including concrete, timber, metal deck, and post finishes to suit different roofing membranes are available. Designers are quite correctly heavily focused on the visual impact of the building and its components. As such, as items such as fall arrest should ideally have minimal impact to this. The system designer must consider if the cable system will be visible from public space or potentially overlooked by other portions of the building or by adjoining buildings. As the system consists of post units at a minimum of 8 meter centers with an 8 mil cable, as an example, you do get systems with 6 mil cable, apologies. The materials themselves provide minimal visual impact. The posts, where required, can be colored to match the roof surface, though in the majority of cases the roof finish is of a grey coloration and the common systems are of the same color, and this is not normally an issue. Even with low-level parapets, the systems are out of sight, as they are, where practicable, maintained 2 to 2.5 meters back from the leading edge. Moving on to the final area of specialization is looking at the collective protection. Ultimately, this is the goal for any system for working on a roof height. By incorporating collective protection in the design, the end user is provided with a safe area where operatives with no additional training can operate. The creation of a physical position of safety, either by ensuring the parapets are of 1100 mil or providing a guardrail with the same dimensions, should be considered and, if possible, adopted as the access strategy for the building. All manufacturers must have test inspection certificates to demonstrate their product meets the required standards, including in the testing regime must be the effect of wind loading. This is particularly important when specifying freestanding guardrail. A review of the local area, known wind history, including max speeds historically. Local topography should also be considered. This applies to all types of products. Installation teams must demonstrate their competence for the installation in accordance with the manufacturer's guidelines. The design team must ensure that the proposed system meets the standard requirements, and the integration of tow boards must be subject to review on a case-by-case basis. Consider proximity to the leading edge, the environments below the roof edge, and the types of work which may need to be completed in the area. Confirm full integration into the building structure where items are fixed. The number of different options, as an example for what we do ourselves at Select Access, we have fixed, we have freestanding, which is weighted units, and we have folding units, which can actually be folded down when not in use, so reducing again the visual impact of the system. Fixed guardrail can be fixed to parapets, detailed in the drawing. Apologies in this drawing. They also can be fixed to the top surface of the roof. There is multiple options available to the design team where this is concerned. Freestanding guardrail allows the system to be installed onto roofs that are already laid without having to create any penetrations. Also the advantage where this is concerned on big systems and big centers, data centers as such, for an example, where you may need to reconfigure the guardrail if there's new equipment being moved onto the roof. As mentioned in the previous slide, building regulations may call for specific coloration for the product to ensure compliance with planning permissions. Your installation company will be able to provide powder-coated guardrail based on a RAL color supplied. Just a brief look at other options when we're considering working at height. When we're working on a roof, we may find mechanical and electrical systems on the roof which we don't want people standing on, walking on, or tripping over. So we can use systems such as step-over systems, as you can see in the picture here, or crossover walkway systems to allow ease of access and keeping the individuals away from the mechanical and electrical systems. By doing this, we increase the longevity of any cladding, lagging, and also the pipe systems, and remove the chance for any damage being carried out. Access ladder systems. Access ladders come in many shapes and sizes, and the design team with their consultant must identify the correct option in relation to ladder access. Where practical, a staircase should be considered for work access. In its simplest form, a ladder positioning bracket with a removable ladder is the simplest, most effective option of access into a space to allow and the height to be gained is minimal. Where this is not an option, fixed ladders can be used. The designer must ensure that the correct ladder system is selected, noting that the access and egress requirement, emergency exit routes from the roof space, must also be designed in, giving two clear options. End user training is required if rail systems are used, ensuring the operative has a harness user training. As part of the access risk assessment, the designer and consultant will apply the following development process to ensure that the correct option is selected. If the correct system cannot be designed, the team must step back and look at other options. When designing access solutions, the completion of the inspection and maintenance of the systems must be included. The inspection must be completed by a specialist company with required training and experience with the systems installed. The service provider must have the required insurance to cover and complete this work, and the designer consultant may recommend more frequent inspection if the surrounding environment is identified as being potentially harmful to the equipment. All systems must be inspected on a 12-monthly basis, with all personal fall protection equipment, harnesses, lanyards, and rope access equipment, davit arms, mushroom posts, for example, must be inspected every 6 months. The inspection team can confirm this if the design has been completed correctly, including access for inspection. The inspection company have a duty of care to the facility owner and the end user to highlight any and all issues identified and recommend remedial action. The instruction for periodic examinations, when looking at EN 365/2004, the warning to emphasize the need for regular periodical examinations and the safety for users depends upon continued efficiency and durability of the equipment, which is why we look at a maximum of 12-month period between examinations of fall and rest equipment, and as I referenced earlier, a 6-month period for when we look at harnesses, lanyards, and rope access equipment. I hope during this presentation we've covered some of the subjects here, what we've detailed here when we're looking at our suspended access equipment, rope access systems, cable-based systems, guardrails, step overs and walkways, ladders and inspection and recertification. I do apologize, I have run through the ladder section rather quickly. It's quite a detailed section in there to have a look at, but I am conscious of our timeline and to give the opportunity for any questions at this point. Thank you for inviting me, and I hope that some of the information that I've given here is of benefit to you. I think the guys will be sharing my email address, so that if you do have any further questions that we don't cover in this next 10-minute period, I'm more than happy to take any and all questions and queries, and I can come back to you at a later date. Thanks very much.
Thanks for that, Graham. We have had one question come in so far, and it is, would it be fair to say that some systems used temporarily should be recorded on the temporary works register on site and assessed by the PDSP?
That's exactly correct. When we're looking at systems, and that actually falls more under when we're looking at construction side of things, which we do temporary cradles, working with a partner in the UK. We do that over here, and yes, the temporary works design is required in those instances, and the same as you would when you're looking at SCAP.
Great, thank you. No more questions just yet. Ben, do you have any questions for Graham?
Always loads of questions.
Oh, Ben, we can't hear you very well.
I'm down a tunnel, am I? Fell into a manhole.
Yeah, you are. You sound like a Dalek.
Oh no. I was just going to ask Graham, is there a maximum height you can upsell from? Like, is there a kind of
the rule of thumb is that everybody says around the 100-meter mark you have to what we call re-belay. The reason for that is you have a stretch and extension in the rope over that 100 meters, which actually brings the diameter of the rope becomes thinner. So the effectiveness of the descent device isn't as it should be. So what we generally say, I always pump for between 80 and 90 meters, a re-belay anchor on the building. So when you drop down to that point, you're then re-belaying another set of ropes onto there, so you're starting afresh. But what we have to be conscious when we're doing these type of things is being conscious of our rescue plan in these instances, because when you actually do that, you're moving somebody further away from the person who may be able to carry out the rescue. So there's a lot of different things that have to be considered when we're talking using rope access over 100 meters. But it can be done. I'm sure a lot of folk possibly listening here have seen rope access teams working regularly in Dubai, for example, on extremely high buildings. So there isn't really any limit there. I personally have worked at in excess of 300-400 meters on flare stacks in the good old bad old days.
Thank you, Graham. We've had another. Oh, sorry, we've had another couple of questions come in. So we've had. Do you find that working at height risks are being adequately controlled during the design stage to remove the need for working at height, as an example?
I have to say, I've been involved in over 20 years in here and in Ireland for certainly the last 14 years, and I'm seeing a steady, a very good progression. To be honest, we're engaged with people like Ben and actually main contractors as well, where people are actually considering this at design stage, so that they can actually build it into the contract package. There is this lovely idea that we can design out working at height, but from a practical point of view, that's not realistic. When we're looking at buildings in the middle of cities, we have to look at alternatives. If we're going down in buildings down side streets, we're not in a position where we can be putting in MEWPs or lorry-mounted hoists. We have environmental impact. But what is happening, there is a much more of a move towards using BMUs and cradle systems. That allows there to be a greater number of people available to work in these systems, where industrial rope access, more so in Ireland, you don't have that many teams working in rope access where you would in the UK. But still, it is a practical, quick solution as well, because the other side of it, when you look at rope access, it is safe, but also you've got very minimal maintenance and running costs for any system that's done like that. But I have to say, certainly, I would say in the last 10 years, in my experience, the consideration for work at height has greatly improved. And what I hope it's proving as well for clients is that they're seeing a reduction in cost, because when it's an afterthought, there is so many other impacts when you're having to come in, retrofit, or do work retrospectively, is infinitely more expensive.
Great, thank you. And probably the final question, because of the time, do you find there is a great deal of importance placed on the production of working at height documents prior to the works, rather than reviewing the contractor on site? That's an interesting one.
Our experience is that everything is weighted evenly, to be honest. I think one of the key things that I personally, if you were talking from a consultancy point of view, is working with the contractor that is doing the installation works, and making sure that the first in kinds and everything's done. All contractors working in this industry are highly experienced and very professional, but it's just making sure that everything's done right from the very start. Now, when it comes to the paperwork side of things, it is heavily documented, but correctly so. It has to be. And saying that, you still have to have that supported by the actions of those carrying out the work. And also, we're finding a lot more interaction with main contractors, where they would actually have their engineers working side by side with our teams to ensure not only is the work carried out correctly, but any works, any clashes in that are worked through quickly and appropriately. I don't know, I think I've covered the question there. Please advise me if there's anything further you'd look for there.
We've just had a thank you there, so that obviously did answer the question. Ben, can I hand over to you for closing comments, please?
Find a mute button. Look, Graham, I appreciate you coming along, having a chat with the lads. As I said, you're my go-to for all things work at height. I appreciate you coming along and spreading the word. As I said, getting there early is the key to it. Though you mightn't have the detail, like most things in construction, you mightn't have the details later on, but coming up with the plan is the most important thing. I think getting that started early is always important. I think you're right, BMUs are going to become more prevalent in Ireland. They've had a bad rep up until now, but as we go up in the world, I think they're going to become part of normal business. So looking forward to seeing how that develops over the next while. But again, thanks very much. Hopefully next time, well, maybe not next time, but over the summer we plan to have an Irish branch meeting face to face. Might try and have a visit to a site, so that'll be something to look forward to over the summer. We might invite Graham along for the crack as well.
It'd be interesting. Thanks for that.
Thank you everyone for attending. As usual, the video will be uploaded onto the RRSM YouTube channel. And if anybody would like Graham's contact details, you can email branches@rrsm.org and we'll arrange for that to be passed on to you. So have a good afternoon or evening wherever you're calling from. Thank you everyone.